Hello and welcome to this Python tutorial. Well, I hope the homework went well. I hope you've obtained some interesting results, and without waiting, I'm going to complete the backward elimination so that you can see if you obtained the same result as what we are about to obtain, and mostly so that you can see how we complete backward elimination up to the end. So let's do this. So in the previous tutorial, we went up to building this regressor without the state independent variable, and that completed the step 5 here of the backward elimination algorithm. And so now we need to go back to step 3 to look again for the independent variable that has the highest p-value, and then we need to compare it to the significant level to decide if we need to remove this independent variable with the highest p-value. So what we simply have to do right now is just to select all this, and all in once this will remove the independent variable from xopt. This will fit the model without the predictor that we just removed, and then we will get the new table with the new results and the new p-values, which is perfect because actually you see in this slide that when we fit this model without the variable that we just removed, we need to go back to step 3, which is of course to look again at the predictor that has the highest p-value, but with the new team of independent variables, so without the independent variable that we just removed. Okay, so let's do this. Okay, so let's select these 3 lines, and you will see that it's all going to be very easy now. All right, so that's the new table. You know, that's the old table, and that's the new table. And you can see that in this new table, we now have 4 independent variables because we just removed one. So just to keep track of what are x1, x2, x3, and x4, we just need to have a look at xopt. So const is this column here with all the ones. x1 is the first dummy variable for state, x2 is the R&D spend, x3 is the admin spend, and x4 is the marketing spend. Okay? And now, so what is the highest p-value? The highest p-value is actually this one, 94%, still way above the 5% significance level. So now what we have to do is to remove x1, that is the first dummy variable for state, from our independent variables. The dummy variables for state will not be part of the final team. Okay, and now not to make any mistake with the index of x2 here, we need to take our matrix x, make sure to take the original matrix to get the correct indexes because, you know, we're removing the indexes from this x here. So that's the original matrix, so that's this matrix. So we need to be looking at the same thing. So the variable that we need to remove is x1 with a 94% p-value, that's the highest p-value, and x1 is, as we just said, the first dummy variable for state. So that's actually this one, and this one has index 1. So therefore what we need to do now is to remove this index 1 here from xopt. So as usual, we're going to follow our method. We're going to copy that, paste it here, and now we're going to remove the index 1. Okay, perfect. And now are you starting to see how easy it is to implement this backward elimination with this script here? We just need to, you know, do some copy paste, remove the indexes, and then select this block of 3 lines of code here, and just press Command or Control plus Enter to execute. We have our new table here, and in this new table, we just need to look at the highest p-value and decide if we need to remove this independent variable that has the highest p-value. So let's see, what is it now? It's actually this one, x2, 0.6, 60%, still way above the significance level of 5%. So that means that x2 here, which is, by the way, the admin spend, has absolutely no impact on the profit. So we clearly need to remove it. So we're going to remove its index from the xopt matrix. And just to keep track of what the index is and not make any mistake, we need to look at our original matrix x, because same thing, we are removing the index from the original matrix of features x. Okay, and so what is this index? So, okay, so we removed the 2 dummy variables. So x1 is therefore the R&D spend, that's the one. And therefore, very clearly, we understand that x2 is actually admin spend. So that's the variable that has index 4, and that's the index we need to remove. So let's press OK here. And now let's, same thing, copy this, paste it here, and let's remove the index 4. All right, our model is finally getting ready. Maybe that's the final team, maybe, you know, because that's the constant. So maybe the independent variables with indexes 3 and 5, that is R&D spend and marketing spend, compose the final team of our independent variable that make the best team to predict the profit. So let's see. We'll find out about that right now. And let's press Command and Control plus Enter to execute this. And let's have a look at this new table with therefore only 2 independent variables. So the R&D spend and the marketing spend. And let's look at the highest p-value now. The highest p-value is 0.06. Oh, by the way, there's 0.000 here for this x1. Well, the p-value here is definitely not 0. We cannot have a 0 p-value, but it's just so small, like something with a lot of zeros and then some decimals in the end. But it's a very small p-value, and anyway, it's way below the significance level of 5%. So the R&D spend is definitely a very powerful predictor of the profit and definitely has a high statistical impact on the dependent variable profit. But as far as the second independent variable is concerned, that is the marketing spend, we can see that the p-value is 0.06, that is 6%. Well, it's actually slightly above the 5% significance level that we set. And by the way, we could have set another significance level of 10%, for example, and in that way we would have kept this independent variable. But if we want to follow thoroughly the framework, like the backward elimination algorithm we have on the slide, well, in that case, we need to remove this independent variable. But don't worry, if you still have doubts about that, we will use later some other metrics to make a better decision about that, like to add a criterion that will help us decide with more sense if we really need to remove this independent variable. But this tutorial is about backward elimination itself. We are not talking about improving the model's performance yet, so we're going to follow thoroughly the backward elimination algorithm, and therefore we will remove this independent variable. So now I think it's clear, this independent variable is marketing spend, and of course this has index 5. So let's copy this, let's paste it here, and let's remove the index 5. Okay, and now let's select all this, press Command and Control plus Enter to execute, and here is our final table with therefore only one independent variable, that is of course the R&D spend, and obviously the p-value is very, very small, which definitely makes the R&D spend a very powerful predictor of the profit. So finally, if we follow thoroughly the backward elimination algorithm, then the conclusion is that the optimal team of independent variables that can predict the profit with the highest statistical significance, the strongest impact, is actually composed of only one independent variable, and that happens to be the R&D spend. And that's it. We are actually done with the backward elimination. So if we take a step back at this tutorial, we can notice that we took quite some time at preparing the backward elimination with this, line where we needed to append this column of ones to our matrix. And then we had to make our regressor using this new stats models library. But then did you notice how fast and easy it was to implement the backward elimination algorithm itself? Because with this 3 lines of code, we just did some copy paste. We had some very efficient look at this table to decide which independent variable we had to remove. And very efficiently, we removed each of the indexes and we obtained very quickly the final result with the final optimal team of independent variables. So congratulations for implementing backward elimination on Python. We're going to do it on R right now. And for those of you who still have doubts about whether we needed to remove the marketing spend, well, don't worry about that. We will use some other powerful metrics that are the R-squared and the adjusted R-squared, and that, by the way, are here, R-squared, adjusted R-squared, and will help us decide with more certainty whether we need to keep or not the marketing spend. Alright, so congratulations again. Thank you very much for watching this tutorial, and I look forward to seeing you in the next one. Until then, enjoy machine learning!